Hello everyone, today we'll be working on chapter 8.5 using intercept form. Alright, let's begin. So to start off with, let's take a look at this core concept right here. So you have already graphed quadratic functions written in several different forms, such as f of x equals ax squared plus bx plus c, which is standard form, and g of x is equal to a times x minus h squared plus k, which is vertex form. Quadratic functions can also be written in intercept form. F of x is equal to ax minus p times x minus q, where a cannot be equal to 0. In this form, the polynomial that defines a function is in factored form, and the x-intercepts of the graph can easily be determined. So a couple things to note. Notice that the x-intercepts are p and q. The one on the left is going to be p, the one on the right is q. And when we take p and q and we add them up, divided by 2, we get the axis of symmetry right over here. This axis of symmetry is halfway between the two. That's why we add them up and divide it by 2. And if the graph opens up when a is greater than 0, and the graph opens down when a is less than 0. So that'll help you figure out your domain and range. Alright, so let's begin. So let's start with the first one. In exercise 3 to 6, and we're doing number 4 for this one only, find the x-intercepts and axis of symmetry of the graph of the function. So for this one, what we want to start off with is figure out what p is equal to and what q is equal to. Go ahead and pause the video if you need to. Okay, so p is the one on the left and q is the one on the right. We'll keep this up here just in case. So p is going to be this one right here, and q is going to be this one. And let's figure out what p is equal to. 1, 2. So that means p is equal to 2. And q, let's go ahead and count this one. 1, 2, 3, 4, 5. So that means p is equal to, oh, q is equal to 5, my bad. So from here, how can we figure out what the axis of symmetry is though? So to figure the axis of symmetry out, we can go ahead and plug it into this equation right over here. So our axis of symmetry is going to be equal to x equals p plus q divided by 2. So we can plug that in right there. So our p is 2, so we're going to plug in 2, and our q is 5, so we're going to do 2 plus 5 divided by 2. Now what is 2 plus 5? 2 plus 5 is 7 divided by 2. And this means that 7 divided by 2 is equal to 3.5. And that means that our axis of symmetry is equal to 3.5. Alright, so the next thing that we need to figure out is we figured out the x-intercepts, 2 and 5, and our axis of symmetry. So we're good. Let me just write it down over here. Axis of symmetry. Oh, it's not working with me. And these are our x-intercepts. Okay. So remember, once again, this is p, and this one's q, and this one's p, and this one's q. And these are our x-intercepts. And when we add them together and divide it by 2, we get the axis of symmetry. Okay, continue the next one. Number 6, g of x is equal to 2 over 3 x times x plus 8. So the same directions as the one that we had previously. So let's go ahead, see if we can move this down. Oh, it doesn't want to move down. Okay. So g of x is equal to 2 over 3x times x plus 8. Alright, so for this one, we're not provided a graph, but how will we be able to find out what our x-intercepts are then? Well, we can just go ahead and find the zeros, because the x-intercept, as you can see right here, is when y is equal to 0. So if we just change our y to 0, in this case we have g of x, so let's make g of x equal to y. So let's have y is equal to 2 over 3x times x plus 8. We're going to make y equal to 0 to figure out what our x-intercepts are. If y is equal to 0, that means that whatever we get for our x is going to be our x-intercepts. So now, as we learned earlier in the year, we can make our t-table now. And we're left, and we need to create our two equations. 2 over 3x equals 0, and x plus 8 equals 0. So now we divide both sides by 2 over 3, which means x is equal to 0. And we subtract 8 on both sides, giving us x equals negative 8. So remember, the one that's smaller is p, and the greater one is q. Which one's smaller in this case? In this case, this one's smaller. So this is going to be our p, and this one's going to be our q. So let's see if we can try to remember what the formula was. See if you can try to come up with it on your own. So pause the video and try to come up with it. X equals p plus q divided by 2. And now we can plug in our p and q. Our p is negative 8, and our q is 0. So we have negative 8 plus 0 divided by 2, which is negative 8. And negative 8 divided by 2 is negative 4. And that is going to be the axis of symmetry. Alright, let's try another one. Let me make this bit a little bit smaller so you can see in the overall. Okay, so that one's number 6. Let's try number 10 in the book. Alright. In exercises 7 through 12, we're doing number 10. Graph the quadratic function, label the vertex, axis of symmetry, and x-intercepts, and then describe what the domain and range of the function is. Alright, so let's see here. Before we do anything, we want to figure out what our x-intercepts are. So, once again, we're going to make our table. So we have x minus 7 is equal to 0. And then we have x minus 3 is equal to 0. So we're just going to set the h of x to 0. We set it to 0 because wherever y is 0 is where our x-intercept is going to be. So then we add 7 to both sides. And we're left with x is equal to 7. And then we add 3 to both sides, and we're left with x is equal to 3. So that means this is my p value, and this is our q value. So from here, we can now figure out what our, let me write this down real quick, intercepts. Now we can figure out what our axis of symmetry is. Let's do that over here. Once again, try to see if you can remember the formula by yourself. Alright, so x equals p plus q. Our p is 3. Our q is 7 divided by 2, which leaves us with 10 over 2. 10 over divided by 2 is 5. So our axis of symmetry is going to be 5. And now, let's see. Let's underline everything we finished already here. We figured out what our x-intercepts were. And we figured out what our axis of symmetry is. And so we need to figure out what our vertex is, what our domain and range is, and we still need to graph it. So with the information we have, we can start graphing some of it. Let's move this away. Okay. Let me see if I can get some space over here. Oh, that's not it. Okay. Let's get a graph in here. Okay. Let's make our graph. It's not working. Okay. Go ahead and try to make your own graph while we do this together. Alright. So here's our graph. Let me label these real quick. This is our x. This is our y. And we're going to go by increments of 2. For the y at least. 2. Let me just put it by 4 here. 12. Okay, so our x-intercepts are x equals 7 and x equals 3. So if we wanted to plot as a point, that would be 7, 0 and 3, 0. So let's go ahead and plot 3, 0 first. 1, 2, 3. So that would go right here. Oh, I'm doing a different color actually. So that would be one of our x-intercepts. And our second point was x equals 7. So let's go to 7. 1, 2, 3, 4, 5, 6, 7. Alright. So now, it looks like we could almost create a graph. But, as we know, parabolas look something like this. However, we don't know where the vertex is. So we need to figure that out. How can we figure out the vertex if we don't have that information? What we can do is, since we know what our x's are equal to, we can just go ahead and plug it back into the equation. Well, not this one actually, the axis of symmetry. We'll need to plug in the axis of symmetry back into the equation in order to figure out where our vertex is at. Okay, so let's do that right here. Let's recreate the equation. Y is equal to negative 4 x minus 7 x minus 3. And since we have this right here, we have this 5, if we plug in 5 for x, we'll figure out what y is equal to. So replace all the x's with 5. So then we're left with negative 4. 5 minus 7 is negative 2. 5 minus 3 is 2. And now we need to figure out what this is equal to. Negative 4 times negative 2 is positive 8 times 2, which is then equal to 16. So now I know what this point's equal to. It's going to be 5, 16. 5, 16. Okay, my laptop's struggling right here. Okay, so now I can go ahead and plug this in here. So 1, 2, 3, 4, 5. Our axis of symmetry is right over here. Let's draw that in green real quick. And our point is going to be on 5, 16. So right up here. So I can go ahead and draw this right here. It's a little messy. Okay. So we created our graph, we found our vertex. What else is there to do? Let's see. So we graphed it, and I would highly recommend underlining or circling every time you finish a certain problem that the question asks, because otherwise you might forget a part of it. So let's work on domain and range now. That's what we have to do now. Let me see if I can erase some of this real quick. Okay. Okay. All right. So let's take a look at our graph. Our domain is our x. So take a look at the graph. How many different points do you think you could possibly put from the x-axis on here? It's infinite. It goes on forever and ever and ever. So for the domain, you would write all real numbers all real numbers. And then the range is a little bit trickier, right? A range, it goes infinitely downwards. However, it does not go infinitely upwards. So the vertex right here, which is 5, 16, is where it ends or begins. So our range would be y is, let me write this down, y is less than or equal to or greater than, y is less than or equal to 16. So that means whatever you plug in has to be 16 or smaller. Okay, so that's how you would figure out your vertex, domain, range, and everything. Let's work on number 4 now. So now we're asked to graph 2x squared minus 8, and we're asked to describe the domain and range. Go ahead and try it on your own, pause the video. Okay, so before we begin this, we're going to need to rewrite this quadratic function in intercept form. So let's go ahead and do that. So we have y is equal to 2x squared minus 8. So we can pull this 2 out in the front. And we're left with x squared minus 4. And then we can go ahead and factor this. When we factor it, we get x plus 2 and x minus 2. And now we can finally figure out what our x-intercepts are. Our x-intercepts are x equals positive 2 and x equals negative 2. So this is going to be our p, and this is going to be our q. Remember, the smaller number is p, the bigger number is q. And with this information, we can figure out what our axis of symmetry is now. So let's go ahead. X equals p plus q divided by 2. P is equal to negative 2, and q is equal to positive 2 divided by 2. Negative 2 plus 2 is what? It's 0. 0 over 2. So that means our axis of symmetry is 0. And once again, go ahead and think about how we could possibly figure out what the vertex is based on the information that we have so far. Right? So far, we cannot create a graph just off the axis of symmetry and the 2 x-intercepts. We need a vertex. Hopefully you guessed it right. If we plug this 0, our x, which is our x value, it will give us, oh, where did my graph go? It will let us know what our y is. So let's see, we have our equation here is y is equal to 2x squared minus 8. Let's go ahead and replace the x with 0. And once we figure out what the 0 is, we'll know what our vertex is. 0 to the power of 2 is 0, times 2 is 0. 0 minus 8 is negative 8. So now we know that our vertex is 0, negative 8. Okay. And I'm running out of space here a little bit. Let's see. Okay, I'm just going to erase a little bit here. Okay, let's make our graph right here. Go ahead and try to make a graph on your own while I do this. Okay, so we're going to go by increments of 2 for this one. Okay, on the y-axis at least. And remember, these are negative. Okay, so let's label our first ones. We have 2, negative 2. So 1, 2. Those are our x-intercepts. And negative 2 right here. And our axis of symmetry is going to be right here. And our vertex is 0, negative 8. So that's going to be right here. So let's go ahead and connect this. Oh, that's not correct. So that is what the graph would look like. And once again, we need to figure out what our domain and range is. As for domain, notice that this will go on forever this way, which means we could put in any x value. However, the graph does not go past this point right here. This is the minimum, right? So that means that our range is going to have to be greater than -8. So let's write that down. Range is y is greater than or equal to -8. And domain is all real numbers. All real numbers. Okay, let's go ahead and try another one. And this is what the graph would look like. This one's a little bit neater than the one I made. And here you can see the x-intercepts, and you can see where the y-intercept, where the vertex is, the axis of symmetry right here. Okay, let's try this one. Find the zeros of x is equal to x minus 1 and x plus 2. Alright, so again, we're going to need to create two equations. We're going to set f of x equal to 0. Alright, so our two equations are going to be x minus 1 is equal to 0 and x plus 2 is equal to 0. Which gives us x equals 1 and x equals -2. And those are going to be our zeros. Let's try another one. Find the zeros of each function. So we're only going to do one for this one. So for this one, let's see here. Alright, so first we're going to begin by taking the 2 out in the front. Right? Let me bring this. We're going to change f of x to y. We're going to bring the 2 out because that's what each monomial in here has in common, which leaves us with x squared. Wait, let me fix this. And this should be -2. Let me fix that. X squared minus 5 plus 5x plus 6. Remember, we do not want to have a negative in the very front, and it should be positive. And when we take a negative out of the front, all the symbols here have to change, right? Because we're dividing -10x by -2, we're dividing -12 by -2, and when we do that, a negative divided by a negative is positive. So here, we can now factor this, and we're left with -2, and when we factor, we get x plus 3 and x plus 2. And when we find the zeros, we're going to do this. X plus 3 is equal to 0, and x plus 2 is equal to 0. We subtract 3 on both sides. We're left with x equals -3, and subtract 2 on both sides. And we're left with x equals -2. And that's how we'd find the zeros for the function. Alright, let's try another problem. So for this one, you're going to match the function with the graph. So we have x plus 5 is equal to x plus 5 times x minus 3. For this one, we're going to once again find what our zeros are. To find that, we're going to set this y to 0, right? That's what the zeros are. 0 equals x plus 5, and 0 equals x minus 3. subtract 5 on both sides, giving us x is equal to 5, negative 5, and x is equal to positive 3. So now we're going to look at these options that we have right here and figure out which one has the x-intercepts of negative 5 and positive 3. And notice here that our a, there is no a here, but we're going to assume it's 1. If nothing is written, we assume it's 1. 1 times this whole thing. So our a is positive, which means our graph is going to be facing up. Luckily, all these graphs are already facing up. So let's go ahead and figure out which ones have x equals negative 5 and x equals 3. So now, hope you had some time to work on this. Let's see. What you need to look at is the scales first. To look at the scales and see which one has, let's start with negative 5. This one has a scale of 2. It's going by 2. So 2, 3. So this one might work, right? This has, well, if you look here, this is negative 3. We want positive 3 and negative 5. So this will not work. So we can cross this one out. What about this one? This is going by a scale of 1. 1, 2, 3. That's not going to work either. We're looking for negative 5, not negative 3. This one is negative 3, which is the same as this one. Don't get tricked by the different looks of the graph. And this one here is going by a scale of 2. 2, 4, 5. Hey, this one might work. It's negative 5, and we need to look for x equals 3. 1, 2, oh, it's going by 2. So 2, 3. So this one might work too. Let's see if we can circle this. If you take a look at the other ones, this one is the only one that will work out. Alright, and the homework is page 455, 3 to 17 odd, 21 through 35 odd.